All right, so here's another sheet that you should have a copy of. We're just going to do, like we've done before, just do a walkthrough of the sheet of generally how to do it and what answers hopefully you'll end up with. Again, not the full solutions, just like a walkthrough and what you can start with and a couple of steps to help you guys along. So the first one here, another graph, basic VT graph, of course, that's where we extracted the acceleration from when we start all this type of stuff. So of course, acceleration on a VT graph is the slope. So all you really want is the slope for the first part. That's generally what you're looking for. So of course, acceleration is the the delta V over the delta T, or the slope during just the first little part. And we can assume just goes up to 5 seconds and goes up to the 10, a little idealized and stuff like that. So just get the slope for that first part and you'll have the acceleration. And hopefully you'll end up with around 1.2 meters per second squared. For the distance for the second part, this is a little bit different. You want to use the DTV. Now you got to be careful because since the V is changing, it's not a constant V, you need to use the average V for the second part. And the first part has nothing to do with this. It's all about the second part. So you get the time for the second part, like how long did the second part last? You look at the V that you started with during the second part. You look at the V that you ended with during the second part. And it goes from like 10 down to 2. And you got to use the average of that second part. Not the whole thing, just the second part. So take the time for the second part, and this is where subscripts can come in handy. Use the time for the second part, use the average V for the second part, and then just crank out your DTV. And hopefully you'll end up with around 90 meters when you're all done. Okay, for the next one, you're driving a car. We got mixed units again, so you don't want to convert that into meters per second. And then you can do your DTV. You got the time, you got the V. So basic, just DTV once you've converted the units, and you're all good. And hopefully around 1850 meters, okay? Which for a Ferrari wouldn't take too long. All right, for the next one, we got a dog. We got a little Scooby-Doo action going on here. Dog starts at 1.6, then is running at 5.4. How long did it take to speed up with the acceleration? Okay. So we're looking for time, and with acceleration, time is the change in V divided by the acceleration. Well, you got the first V, you got the last V, you can find out how much the V changed by, then just divide by the acceleration which is given to you, and hopefully you'll end up around 3.2 seconds when you're all done. How far to go? Again, DTV type thing. The V is not constant, so you have to use the average V. So you got the first V, you got the last V, find the average of those V's, and then apply that to the time, and you can calculate the distance. And hopefully around 11.2 meters when you're all done. And last one here, we've got a spaceship going on. First thing, notice you got a distance and you got a time. So you got that distance and time. Of course, the distance and time, you can calculate speed. Now, it's talking about the speed changing a little bit here. So if I do DTV, that'll give me the average V. So I know the final V. I know it ends at 28. So I know the end point is 28. I also know the average V by using the calculation of distance divided by time. And that average V would be in the middle. So I can sort of work backwards to figure out what speed the spaceship started at. And hopefully if you do that, you should end up with around 20 meters per second for the initial V. Okay, so there's just some of the general steps of how to do these basic DTV, VAT type calculations, and hopefully the answers that you will end up with.